Okay, GED is in love with this style of question, so I'm going to read it out loud. Mike went canoeing. He traveled 10 miles upstream against the current. Then he traveled 10 back downstream with the current, 10 miles. In still water, the canoe travels at a rate of 8 miles an hour. Let C represent the speed of the current. Which expression best represents the total time it took? Hint, use the formula sheet because the formula sheet's going to help you. Formula sheet's not going to help you on this one because it is worded in such a bizarre way that it's best to ignore the formula sheet. So this is what we're going to do. We're going to imagine we're at the test. It's question 17. We still have 29 questions to go. And we're starting to feel that fatigue and frustration. And then this question comes up where the whole premise of it is the idea of having a nice day canoeing and then ruining it by doing algebra. Now, it's 10-mile trip. One of these is right. There will be algebra questions where you don't solve to try to figure out how much time it took or how fast the river was going or you know, the current, whatever. There'll just be times where they say, which piece of math would you use? This is what, like in math class, when the teacher would say, that's cool, you got the right answer. 17 was right, but you got to show your work and you got to do it the way I say. And it's just like, yeah, isn't the right answer good enough? So this is why they ask these questions. Which thing would you use to get there? So we're going to take a deep breath. Imagine we're stuck here and we're going to on the test, and we're going to look at our answers. So here we go. He goes upstream. He goes downstream. That means there's two parts. So now we look at our answers. Okay, there's two parts there. There's a before, a chunk of math, and a chunk of math on the other side. Same thing here. Now the words are different or whatever, the parts are different. This is 2 times something, so that's kind of like it. And the last thing, those are the two parts. So we sort of get it. Okay, one part is going upstream against the current and the other part's going down the stream. Okay, so we get rid of all this and we think upstream. That is Mike canoeing against the river, which sounds terrible. You should float down the river, Mike. So here's the rule. Distance goes on top, rate goes on the bottom. Now there is something on the formula sheet that has a distance formula, but it doesn't write it this way. So that's why I'm saying it's not super helpful. It also spells doctor. So these questions give me a headache. So spell out doctor, D on top, R on the bottom. And then against the current, if you're going against the current for the rate, that would be a negative. You have to work harder. It's like running with the wind in your face. It only makes it more difficult. So that's the against the current part. Then he goes down the stream, relaxes and floats or whatever he's doing. Distance still remains on top. We're going to add them together. The distance remains on top and the rate goes on the bottom. Now, the only difference is he's going with the current, and that would be a positive. If you're tired, going with the current's pushing you, you're going a little bit faster, that would be a plus. Now we plug in what we have. The distance is 10. The rate is 8. And that's our answer. So distance top, rate on the bottom. And think about it. Terms like miles per gallon, miles per hour, the distance is almost always on top. So if you drive at a rate of 20 miles per hour, distance on top, the rate is kind of on the bottom, how we do it in an hour. So they also ask it with airplanes, blimps, hang gliders. So it's either something that's floating in the water or something that's floating in the air, and there's wind or the water moves. In that way, the GED can ruin your next canoe trip.